described installation isn't ideal, but acceptability hinges on local built-in codes and specific circumstances. Typically, an old work pancake box is installed by cutting a hole in the drywall large enough to accommodate the box, then securing the box to the side of a stud using screws. This secures the box and provides a stable base for the light fixture. Installing a pancake box on two pieces of one straw attached to the drywall with screws is less secure than directly attaching it to a stud. The one straws may not adequately support the box and light fixture. Additionally, the screw securing the one straws to the drywall might not penetrate the stud, further weakening the installation. If concerned about the installation's safety or stability, consider removing the pancake box and reinstalling it correctly. Consulting a qualified electrician for their professional opinion and recommendations is another option. Several factors determine the correct and safe installation of electrical boxes, including pancake boxes. These include box fill calculations, support requirements, and applicable codes. Firstly, box fill calculations are crucial. The National Electrical Code, or NEC, dictates how many wires, devices, and fittings can safely occupy an electrical box. Overfilling a box can lead to overheating, insulation damage, and potentially electrical fires. The NEC provides tables, such as Table 314.16, that specify the maximum number of conductors permitted in standard boxes based on their size. These calculations involve considering the volume of the box, the number and size of conductors, device yokes, internal cable clamps, and equipment grounding conductors. Each conductor entering the box counts towards the fill calculation. Conductors originating outside the box and terminating inside the box, or conductors that pass through the box without splice or termination, are counted. However, an exception exists for equipment grounding conductors, where multiple conductors are combined and counted as a single conductor based on the largest grounding conductor entering the box. Device yokes, such as switches and receptacles, also count towards the box fill. Each yoke counts as two conductors based on the largest conductor connected to the device. Internal cable clamps and fixture studs are also counted as one conductor based on the largest conductor entering the box. To perform a box fill calculation, follow these steps. 1. Determine the box volume from the box's marking or manufacturer specifications. 2. Count the number of current carrying conductors entering the box. 3. Add 2 conductors for each device yoke. 4. Add 1 conductor for all equipment grounding conductors. 5. Add 1 conductor for internal cable clamps, if present. 6. Compare the total conductor count to the maximum allowed by Table 314.16 for the given box volume. If the total exceeds the limit, a larger box is required. Secondly, support requirements are vital for ensuring the box remains securely mounted. The NEC mandates that electrical boxes must be securely fastened to a structural member of the building or a suitable support system. This prevents the box from becoming dislodged, which could damage wiring and create a safety hazard. For surface-mounted boxes, such as pancake boxes, direct attachment to a stud or joist is preferred. Screws, bolts, or other appropriate fasteners should be used to securely attach the box to the structural member. When direct attachment is not feasible, the NEC permits the use of independent support wires, brackets, or mounting systems specifically designed for supporting electrical boxes. These supports must be capable of withstanding the weight of the box and any attached fixtures or equipment. For boxes mounted in existing walls or ceilings, commonly referred to as old work installations, specialized methods are often necessary. These methods include using old work clips or brackets that grip the back of the wall or ceiling material to secure the box in place. These clips or brackets must be listed for the intended use and provide adequate support for the box and its contents. For pancake boxes, which are typically shallow, the support requirements are particularly important. Because of their limited depth, pancake boxes are often used in situations where space is restricted, such as mounting fixtures close to a ceiling or wall. This means that the box may be subjected to greater stress and vibration, making secure support even more critical. When installing a pancake box in an old work situation, it's often necessary to reinforce the mounting surface. This can be achieved by adding wood blocking behind the drywall or using specialized mounting plates that distribute the load over a larger area. These reinforcements provide additional support and prevent the box from pulling away from the wall or ceiling over time. Thirdly, adherence to applicable codes is mandatory. Electrical installations must comply with the NEC and any local amendments adopted by the jurisdiction. These codes provide minimum safety standards for electrical work and are designed to protect people and property from electrical hazards. Code requirements for electrical boxes cover a wide range of topics, including box fill, support, grounding, and conductor protection. Failure to comply with these requirements can result in code violations, fines, and potentially dangerous conditions. Electrical inspectors are responsible for enforcing the NEC and local codes. They review electrical plans, inspect installations, and issue permits to ensure that electrical work meets safety standards. Before beginning any electrical project, it's essential to obtain the necessary permits and familiarize oneself with the applicable code requirements. When installing electrical boxes, it's important to select the correct type of box for the application. Different types of boxes are designed for specific uses, such as surface mounting, recess mounting, or wet locations. Using the wrong type of box can compromise safety and violate code requirements. For example, when installing a box in a damp or wet location, such as a bathroom or outdoor area, a weatherproof box must be used to protect the electrical connections from moisture. These boxes are designed to prevent water from entering the box and causing corrosion or electrical shock. Similarly, when installing a box in a fire-rated wall or ceiling, a fire-rated box must be used to maintain the integrity of the fire barrier. These boxes are designed to prevent the spread of fire and smoke through the wall or ceiling assembly. In addition to selecting the correct type of box, it's also important to use the appropriate wiring methods. The NEC specifies different wiring methods for different applications, such as non-metallic sheet cable or NM cable, rigid metal conduit or RMC, and electrical metallic tubing or IMT. Each wiring method has its own set of requirements for installation and support. For example, NM cable must be supported at intervals not exceeding 4.5 feet and secured within 12 inches of each box or fitting. RMC and EMT must be supported at intervals not exceeding 10 feet and secured within 3 feet of each box or fitting. Grounding is another critical aspect of electrical box installation. All metal boxes must be grounded to provide a path for fault current to flow back to the source in the event of a short circuit. This helps to protect people from electrical shock and prevent equipment damage. Grounding can be achieved by connecting a grounding conductor to the box using a grounding screw or clip. The grounding conductor must be sized according to the NEC and connected to the building's grounding electrode system. In addition to grounding the box, it's also important to ensure that all electrical devices and equipment connected to the box are properly grounded. This can be achieved by connecting the grounding conductor from the device or equipment to the grounding terminal in the box. The grounding terminal is typically identified by a green screw or a green wire. Finally, it's important to follow all manufacturer's instructions when installing electrical boxes and related equipment. These instructions provide detailed information on how to install the product correctly and safely. Failure to follow these instructions can void the warranty and potentially create a safety hazard. In summary, installing electrical boxes correctly and safely requires careful attention to detail and adherence to applicable codes and standards. By following the guidelines outlined above, you can ensure that your electrical installations are safe, reliable, and code compliant. If you are unsure about any aspect of electrical box installation, it's always best to consult with a qualified electrician. The correct installation of a pancake box also involves selecting the right size and type of box for the specific application. Pancake boxes come in various sizes and shapes to accommodate different wiring configurations and mounting requirements. When choosing a pancake box, consider the number of conductors that will be entering the box, the size of the wiring, and the type of fixture or device that will be mounted to the box. It's important to select a box that is large enough to accommodate all of the wiring and devices without overcrowding. Overcrowding can lead to overheating and installation damage, which can increase the risk of electrical fires. In addition to size, the type of pancake box is also important. There are several different types of pancake boxes available, including metal boxes, plastic boxes, and non-metallic boxes. Metal boxes are typically used for surface mounting and provide excellent protection for wiring. Plastic boxes are lightweight and easy to install, but they may not be as durable as metal boxes. Non-metallic boxes are similar to plastic boxes, but they are made from a non-conductive material that provides an additional layer of safety. When selecting a pancake box, it's important to choose a box that is listed by a recognized testing laboratory, such as Underwriters Laboratories or all. Listed boxes have been tested to meet safety standards and are suitable for use in electrical installations. The listing mark will be visible on the box and will indicate the type of box, the maximum voltage and current rating, and any other relevant information. Preparing the wiring before installing a pancake box is also essential. The wiring should be properly stripped, spliced, and terminated to ensure a safe and reliable connection. When stripping the insulation from the wires, use a wire stripper to avoid damaging the conductor. The amount of insulation that needs to be stripped will depend on the type of connector or terminal being used. The stripped wires should be twisted together tightly to create a solid connection. Use wire connectors to splice the wires together securely. Wire connectors come in various sizes and types to accommodate different wire gauges and applications. Choose wire connectors that are listed by a recognized testing laboratory and are suitable for the type of wiring being used. When terminating the wires to the terminals in the pancake box, make sure to tighten the screws or clamps securely. Loose connections can cause arcing and overheating, which can lead to electrical fires. Use a torque screwdriver to tighten the screws to the manufacturer's specified torque. The final step in installing a pancake box is to test the installation to ensure that it is working properly. Use a voltage tester to check that the voltage is correct and that there are no shorts or ground faults. If the installation is not working properly, troubleshoot the wiring and connections to identify and correct the problem. By following these steps, you can ensure that your pancake box installations are safe, reliable, and code compliant. Always consult with a qualified electrician if you have any questions or concerns about electrical work.